Hello and welcome back. In our previous video, we noticed a slight discrepancy in the number of rows between the initial table and the tables after merging. Let's revisit this issue. We can see that the number of rows in the sales table is 50,000. However, in both sales 1A and sales 2A, the row count increases to 50,066. To better comprehend this difference, let's delve into a simpler example. Consider two tables I've created, DF1 and DF2. Both contain information about various stores. The DF1 table provides data for stores 1 through 6 and includes a second column for sales volume. I've chosen numbers that are easy to track. The DF2 table presents details about each store's inventory. Notably, Store 2 and Store 5 are omitted while Store 9 is included. You'll also notice that Store 1 appears twice in this table. It's a duplicated row with two inventory entries. Let's merge these tables. This time, we'll add a new argument, how, into the .merge method parameters. We'll also assign different values to this argument. Firstly, let's create a left merge table. From the output, we see that the inventory information for rows 5 and 6 is omitted, displaying as NaN. The left merge table contains more rows than DF1. Store 1 appears twice because it was duplicated in DF2. The sales volume value for Store 1 is also repeated in both rows. For right merge, the process is identical, but we use DF2. The output shows only rows from DF2. You might have guessed that a right merge is equivalent to a left merge if we swap the tables. Let's now pass inner to the how argument. No NaN values are displayed, but Store 1 is still repeated. Also, if we don't pass a how argument during merging, the result is the same as an inner merge because inner is the default value for how in Pandas. Finally, when we pass outer to the how argument, we get data from both tables. Now, let's revisit the sales table from our previous video. We'll create a new table by merging sales and FX rates, naming it Sales 1C. This time we pass left to the how argument. We noticed that the row count in Sales 1C is even greater than before. This implies that previously, we only displayed the inner merge of sales and FX rates. On examining the value column of Sales_1C, we find some empty cells, suggesting that not all combinations of date and currency from the original sales table are available in the FX rates table. Let's check FX rates for duplicates using the .duplicated method in Pandas. This method is applied to the table of interest, and we need to specify the columns to check for duplicates. In our case, these are date and currency. The Pandas output shows a column with false for unique rows and true for duplicates. To see the number of duplicates, we run the .sum method on this output. In our next video, we'll locate these missing entries and show you how to identify empty cells. Let's now check if there are duplicates by the combination of day, currency, and value. The result is 0, meaning that while there are repeated values for the same day and same currency, they have different values. The reason for this isn't explicitly given in the Kaggle data and isn't essential for our current understanding. However, in real-world scenarios, understanding such nuances is critical, as data analysis extends far beyond mere data manipulation. So, in this video, we've looked at different ways of merging tables in Pandas, and how this affects the number of rows in the merged table. We've also learned how to check for duplicate rows, and that the .duplicated method can help us with this task. In the next video, we'll delve deeper into the .duplicated method syntax and demonstrate how you can identify exact duplicate rows. Additionally, we'll explore how to filter tables and add new columns to them. If you found this video helpful, please give it a like, share it, and leave a comment below. Don't forget to subscribe to our channel for more tutorials like this one. Stay tuned, and thanks for watching.